Welcome to solverfy.
We're asked to show that if we're given an undirected graph with n vertices, then no more than the floor of n over 2 to the k trees remain after the first step of Solon's algorithm has been carried out, and the second step of the algorithm has been carried out k minus 1 times. So let G be a connected weighted undirected graph with n vertices. And let Pk be the statement Solon's algorithm has no more than the floor of n over 2k trees remaining, after the first step and the next k minus 1 steps. Have been carried out. And we'll prove this by induction. So for the base case, we have that k is equal to 1. So as part of the algorithm, we'll construct a forest of n trees where each tree contains one vertex, then we know that every new tree that will be formed in the first step will contain at least 2 of the n trees. This is because each of the n trees has to be connected to a new tree. And so there are at most n over 2 new trees. And since the number of trees is an integer, this means that there are no more than the floor of n over 2 trees. And we see that in this case, statement P1 is true. For the inductive step, let Pm be true for some m greater than or equal to 1. So it follows that the algorithm has no more than n over 2 to the m trees remaining after the first step, and the next m minus 1 steps of the algorithm have been carried out. We want to prove that Pm plus 1 is true. So start from a forest with at most n over 2 to the m trees. At most the floor of n over 2 to the m trees. My mistake. We know that every new tree that will be formed in the next step will contain at least 2 of the at most floor of n over 2 to the m trees. Contain at least 2 of the at most floor of n over 2 to the m trees. This is because each of the at most n over 2 to the m floor trees has to be connected to a new tree. So there are at most the floor of n over 2 to the m over 2. Well, I guess first I'll just do there are at most the floor of n over 2 to the m divided by 2, which is equal to the floor of n over 2 to the m plus 1 trees. So it follows that statement Pm plus 1 is true. Pm is true. So by principle of mathematical induction, it follows that Pn is going to be true for all n greater than or equal to